Welcome to setting up table partitioning. In order to create a partition table, we have to create a couple of objects first. First thing we need to create is a partition function as well as a partition scheme. So the partition function is going to define the breakpoints between the partitions. It's also going to tell us what data type we're going to be using and whether we're going to be using range left or range right. So the breakpoints that we're going to specify are going to determine exactly what data is going to go into which partition. So if we define our partition as being January 1st of every year, that's actually January 1st as of 12 midnight, 0 minutes, 0 seconds, and 0 milliseconds. If we're defining as range left or range right, that's telling us what range the actual value within the breakpoint is going to go into. There's some really good blog posts out there about how to select range left or range right. The best one out there is actually written by Kimberly Tripp, and you can find it on the SQLskills.com website. Or if you just Google for Kimberly Tripp range left table partition, that'll get you the blog post that you're looking for. She's by far got the best blog post on the subject available. The partition scheme works with the partition function and tells SQL Server what file group to save each of the partitions to. The partition function is going to be bound to a specific partition scheme. When you create the table, your table is going to be created just like any normal table would be, with a create table statement, specify all your column names. The big difference is when you get to the end of the create table script. Instead of specifying on and then listing a file group, you're going to specify on and then a partition function and specify the column that you're going to be partitioning by. This doesn't always make a whole lot of sense with slides, so let's go ahead and take a look at a demo and see if this makes a little more sense that way. So you can see here, I've got a T-SQL script already set up. So I'm going to scroll through kind of the first chunk of this because it's not particularly relevant, it's just setting up the database. So I'm creating a new database called Partition Demo, and I'm adding a bunch of file groups to that. Then I'm adding one file to each one of my partitions that I'm creating. So the next piece here is the first important part we really need to look at. So this is the create partition function that we're going to be looking at. So here we're creating the actual partitioning function that we're going to use. Now this isn't a traditional SQL Server function, so this isn't, something I can embed T-SQL code within. I'm simply specifying range left and then a comma-separated list of values. In this case, I'm going with January 1st for each year. You can see here I've got my partition function named myPartFunction, and I'm using the data type datetime. The data type you specify here should be the same data type as the column that you're going to be using within your table to actually partition the data. The next thing I'm creating is the partition scheme. You can see here I'm just using create partition scheme, myPartSchema, as partition, and then the name of the function that we're going to bind this scheme to. Now you'll see here I'm actually creating two as part of this demo, and that's because I want to show some of the functionality of table partitioning. In this first scheme, I'm creating the function with all the data going to the primary file group. In the second scheme, created just beneath it, I'm actually specifying the specific file groups that I want the data to go to. Now you can do it either way. It depends on what your goal is with table partitioning. If our goal with table partitioning is simply to use what's called partition elimination, where SQL Server only scans through a small portion of the table instead of the entire table, then we can simply use the all to primary, because we aren't too concerned with controlling which disk the data goes to. Now with the second function, because we're specifying the specific file groups that the data goes to, in this case we're actually making a concerted effort to put the data on different file groups, and therefore probably different hard drives. If, for example, I had old data sitting on slow SATA drives, faster data on Fibre Channel or SAS drives, and the newest data on flash drives, when I create the files that make up these file groups, FG1 through FG8, I would put them on the appropriate kind of disk. FG1, 2, 3, 4, and 5 probably on slow SATA, FG6 and 7 on either Fibre Channel or SAS, depending on what I'm using, and then FG8 on my flash drive. So I'm going to go ahead and create these 3 objects real fast. You can see here you get a warning displayed, and in this case the warning is the same for both. Primary is marked as the next used file group in partition scheme and then the name of the scheme. So the reason for that was if you look at the function that I've created, you'll see I have 7 values, 2001 through 2007. This means I have 8 partitions. Don't forget, these are simply breakpoints between the data. These aren't a left-bound or a right-bound value. So I can have data from 2000 in partition 1 and data from 2007 and higher in partition 8. If a partition is empty, it does still exist. So that's why I get this next use file group in partition scheme message. For the all to, that's a given. I'm telling it all data is going to go to the same file group, including the next partition. Well, with that second scheme, my part scheme 2, you'll notice that I've actually got 9 file groups listed, FG1 through 8, and then the primary file group. So because I've got primary listed as the 9th file group, SQL Server automatically knows if I add another partition by doing a range split, then that new partition will be created in the primary file group. We're going to look at how to do that later on in the demo. The next thing we're going to do here is go ahead and create a table. We're going to create 2 tables, one on each scheme, just so we can see kind of that they work the same way. In this first create table statement, we're creating a table called order history. We're giving it an ID column, an order date, a due date, and an account number. We're specifying a primary key of my ID and the order date on my part schema order date. Now, the reason I'm creating the primary key like I am is because in order to partition an index, the column that we're going to use to partition the index has to be a key column of the index. So in this case, the primary key is going to be the clustered index for the table. So I have to have a column from the primary key as the column I'm going to partition by. So that's why I've got the order date as a member of the primary key. In the real world, I probably wouldn't go with this scenario. I'd probably use my ID as the primary key, building the clustered key on order date, or maybe on my ID and order date, depending on how I'm going to be using this table. You can see I've done the exact same thing for order history 2, simply binding it to the different schema, my part schema 2. Let's go ahead and create both of these tables. I'm going to go ahead and run the next part while I talk about it. It takes a minute to execute. So in this section here, I'm simply adding data into the table. I'm loading up my tables with data from the AdventureWorks 2012 database. So this is just so I can get a bunch of data into the system. So you can see here for the order history table, I'm just doing a quick insert of all the data from sales order header. For the order history 2 table, I want to load that up with a little bit more data. So I'm doing that with the same insert statement, but using the go with 110 after it. Now you'll notice the red squiggly. That's not actually an error. That's just Management Studio not realizing what I'm doing. There's a feature that's built into Management Studio and SQL CMD, whereas if I run the statement go with a number after it, it will execute that batch however many times I specified by the number. So in this case, I ran the batch 110 times. So if I look at the output window, you'll see I did a single insert. That was the first insert into order history. And then it says begin execution loop. And it then does the insert over and over and over again. If we scroll to the bottom, it actually says batch execution completed 110 times, telling me exactly what I've just done. Now, another thing to know about table partitioning is we have this function called $partition. We're going to talk about the $partition function more in the next video.